Protecting data from unauthorized access is a big concern for most people when moving to the cloud. Azure Storage provides different security layers, which includes features to restrict access to your data and also enable access to users, groups, and applications that you have authorized. We will discuss three major ways of authenticating to the data plane, which are by using storage account keys, shared access signature, along with the related features called storage access policies, and how to authenticate the blob and queue storage by using Azure Active Directory authentication. For access control, Azure provides two layers. First is the role-based access control, or RBAC, and access control list, or ACL. Next, we will examine how you can configure Azure Storage so that Azure Storage can only be accessed from certain virtual networks in Azure that you assigned access to, or from a range of IP addresses from the internet. So you can effectively prevent your storage account from being publicly accessed from the internet. And then we will discuss encryption in transit to ensure the integrity of data when it's moving in and out of Azure. And then we will discuss encryption at rest, including looking at how to use your own encryption keys to encrypt blobs and files. And at last, we will quickly look at newly added feature, Advanced Threat Protection, which monitors suspicious activities and send you alert through Azure Security Center. Thank you. In this lesson, we will discuss about storage account access keys. So right now I'm in my storage portal, and on the left side we have menu. And if you go down a little bit, you can see the access keys in setting. So let's click here, and you can see here the storage account name, as well as you can see the two keys here, key 1 and key 2, and both keys are already generated by Azure. And for every key, you can also see the connection string. And connection string is nothing but an extension of key. So you can see both the account name here, as well as you can see that account key is also embedded here. So these keys are like a password to enter into your storage account. If you're giving these keys to others, that means you are giving them complete access to your storage account. They can read, write, and change the data, as well as they can create the containers and tables and queues, and delete the data and resources. So for every storage account, there are two storage account keys. And you can use these keys from code via the storage client libraries, or use them with the PowerShell or Azure CLI, or you can use them in Azure Storage Explorer or AZ Copy. So when application uses the access keys of the storage account, it is likely to store the key in the config file, which can cause a possible security risk if the key has ever been compromised. So for example, let's say you give the key to some administrator in your company, and one of them decided to leave the company. Now you would want to remove the access by changing the keys. So you would want to pass the new key to anyone who had the keys before. So what would I do to make that happen is I would just make sure all of my client application uses the key 1. And when the time comes to regenerate my keys for whatever reason, maybe I have a policy to do it this on a regular basis, or maybe I do this reactively when I have some sort of a suspicious that my keys have been compromised. I will simply come to the portal and I will regenerate my key here, and it will ask me the confirmation that current key will become immediately invalid. So before I regenerate key 2, I want to make sure that all my existing applications are shifted to key 1. And when I'm sure about that, I can regenerate this key. And then I will shift all of my applications to key 2. so that I can also regenerate key 1. And once I'm sure that I have shifted all of my applications to key 2, I can just regenerate the key 1 also. So now both of my keys have been regenerated. If you're thinking, what the heck is this and how troublesome it could be, actually you are right. And this is an old way of authentication, and it is no more used in production, and it is also not recommended to use in production now. It's always a good idea to work on the principle of least privilege, which means to only give users and applications the minimum permissions they require to perform their tasks. Giving them a storage account key is not a great approach to achieve this. So there is another type of token you can provide, and that is called shared access signature. A shared access signature is a string that contains a security token, and it can be attached to a URL to a resource in Azure. A shared access signature is often referred as a SaaS token, and it allows you to specify permissions and a range of time for which access is valid. So once again, I'm in the portal in my Azure Data Lake account, and on the left hand side menu, if you go a little bit down here, you can see shared access signature. So let me click here, and here we can see that we have a form, and if we fill all these options, and in the end if we click on generate SaaS and connection string, we will get the SaaS string or shared access signature string. So let's fill out this form. So at the first we have to choose which service we want to give access. So for example, let's say I want to give access to only blob, and I want to give access to blob object, and what kind of permission I want to give. So let's say I want to give only read permission, so I can check other checkboxes here. So I am giving now here the read permission on blob object, and then we can go a little bit down here. We can choose the time, the start time and expiry time. So for example, I can choose time here starting from today, and let's say maybe for 2 days I'm giving this access starting from 5 p.m. today and around 1 a.m. on 5/11, and this is my local time here. Now this will bound the access for this time range only, and here we can also restrict the IP addresses. So you can give a one particular IP address, or you can give the range of IP addresses. So any request which is not coming from these IP addresses will invalidate immediately. And after that, and here we can also enforce to allow only requests which are coming from HTTPS. And here we need to choose one of the access keys. So you know that we can generate access keys here, and this SaaS token will be tie up with one of these access key. So you want to make sure that you tie up with the access key which you are not going to change very soon, because if you regenerate the access key, your SaaS token will also become invalid. So let me choose the key 1 here, and once everything looks good here, I can click on generate SaaS and connection string, and this will generate the SaaS token here. So since here I selected only blob, and that's why I can see the blob SaaS string here. But if you would have selected other services, you would see multiple strings here. So now we have got this connection string, and we have got the SaaS token, and we have also got the endpoint here, the complete Bob service endpoint for this SaaS token. So the SaaS token here is really the key, and you can see that it begins with the question mark here. This is what would be appended to the end of any request that come into blob storage, and with this appended, it would pass in this credential, if you will. It would allow the access to the resource that's being requested. Now once this SaaS token has been generated, you really want to copy this out and store it somewhere. Save it, because it's not going to be available in the portal, and you are responsible for holding onto that. And then of course you do need to be really careful with this URL, because this is going to delegate the access to anybody that owns or gets a hold of this URL. So if you passed it to one person and they forward it to somebody else, both of those individuals would have access to the resources defined in the SASH token. So Azure does not track them once they are generated. So if you generate a shared access signature with an expiry date of 1 year from now, the only way you can invalidate it is to regenerate the storage account key that was used to generate the SASH token. That way, when someone tries to use the SASH token, Azure will attempt to recreate the signature of the parameters being passed in, using a different storage account key than the one that was used when the SASH token was created, and then comparing the signature to what's passed in with the SASH token will fail. So if you're going to use SASH tokens, it is best to use them in conjunction with something called a stored access policy. A stored access policy is a set of constraints that can be used by multiple shared access signatures. A stored access policy is defined on a resource container like a blob container, the table, queue, or file share. This policy is made up of the permissions as well as the start date and end date. The storage access policy lets you create a group of permissions and reuse those with your SASH tokens, which is convenient. But where it's really useful is in revoking access to SASH tokens that reference it. Because a SASH token is just a string. Anyone who gets hold of it can use it. So unless you wait for the SASH token to expire, or you regenerate the storage account access key that was used to create the SASH token, the shared access signature continues to be valid. But if you have your SASH token reference to stored access policy, you can just delete the policy or change its expire time, and this makes revoking SASH tokens a lot easier. And it's a recommended way to use a shared access signature. So from security point of view, shared access signature or SAS is better than the access keys. But from maintenance point of view, having to update SASH tokens all over the place could be error prone and time consuming. Thank you. We have talked about storage account access keys and shared access signatures, which are the first two ways to access the data plane of your storage account. And until mid-2018, they were the only way to access the storage account. Microsoft has introduced Azure Active Directory Authentication, which means you can grant access to your storage account to Azure Active Directory Identities. Azure Active Directory is an enterprise identity provider, essentially providing identity as a service. It is globally available from pretty much any device. I can be on my PC, I could be on my iPhone, an Android device, a Linux machine, a Mac machine. It doesn't matter. It supports standard-based protocol, which means I can pretty much use it from anywhere. Now, when I say Azure Active Directory Identities, I mean a user, a group, or an application principal. And as you know, application principal is an application that's being registered in Azure Active Directory. This gives the application an identifier in Azure Active Directory. And this identifier can be assigned to roles in the Azure Active Directory storage account in order to access and modify data. You can assign an role-based access control or RBAC role to an Azure identity at the subscription level to grant access to all the blobs and queues in the subscription. So for example, all the storage accounts within the subscription will have the access. Or you can also assign this access at the resource group level, or at the storage account level, or even scope down to a particular container in the blob service or single queue level. So now I'm in my Azure portal, and here if you search for Azure Active Directory, you can find it here, Azure Active Directory. So let me open it. So you can see that we can use this service to manage users or groups, and we also have app registrations here. So we can go and look into users. So right now I'm the only user here, but the point is you can add more users here, and you can manage their passwords and other settings. You can see the logs and sign-ins and all. And if you go back, you also can create a group here, and within every group you can add multiple users, and then you can define the access policies at the group level, and all the users within the same group will inherit the same access policies. And of course you also can register the app here to create a service principal and use that service principal ID and access key to log in and access other Azure services. The real impact of this type of authentication is that you no longer need to store credentials within your application. Now, let's say you have got a web app running in Azure App Service, and it needs to read or write blob in an Azure storage account. Previously, you would have had to store the storage account key in a config file, or more likely, you would store a shared access signature that needs to be updated every time the expiry date is reached. And from a security standpoint, having apps use the storage account key is not ideal. And from maintenance point of view, having to update SASH tokens all over the place could be error prone and time consuming. Using Azure Active Directory authentication to authenticate and authorize apps to access Azure storage is an ideal solution. And really it's a way a lot of us have been doing it for years on premises, where you will often grant access to the database or a file share to the identity that the IIS app pool is running under. So it feels like an intuitive approach to authenticating apps. Thank you. In this lesson, we will talk about access management or role-based access management. So once again, if I open any resource in my portal, for example, Gen2 Lake, I can see the access control or IAM. IAM stands for Identity and Access Management. It is important to have an understanding of Microsoft Azure role-based access control or RBAC. Role-based access control or RBAC is used to delegate resource administration. So what I mean by that? Well, imagine, let's say you got an IT administrator that is responsible for managing virtual machines. Well, we could use a role assignment to limit that administrator so that they can only manage those virtual machines. So for example, the virtual machine contributor role would have the necessary permission to work with virtual machines. So let me try to add role here, add role assignment, and I can see that I have so many roles here. Actually, there are more than 60 built-in roles in Microsoft Azure, and roles will vary depending on specific resource that you are trying to setting the role assignment on. For example, if I look at the storage account right here, the roles I have for storage account will be different if I look at the roles for virtual machines right here. With RBAC, roles get applied to a scope where the permissions are effective. The scopes start with management groups. The management groups are used to organize multiple Azure subscriptions. We could also apply roles to a subscription, for example, a role assignment at the subscription level, then that will flow down to all the resource groups and resources within that subscription. It gets inherited. But if we want a bit more granular control, we might use a role assignment at the resource group level. Of course, if we could also do it for an individual resource. Say I want to specific administrator to have access only to one deployment of SQL database in Azure. Well, I can do that. I can grant the role assignment to give them administrative privilege over that single individual resource. So we know now that roles can be applied to a scope. Roles also have to be assigned to items that will have those permissions within the roles. So you can assign roles to an individual users. You can also assign role to an individual group, or you can also assign a role to a service principal, which means you can assign these roles to a other application. For example, you can assign a particular role to data factory, let's say the contributor role, so that data factory has access to the database. So I'm back to my portal, and I want to take a minute and explain a little bit more about these inbuilt roles. So for example, once again, if I click on add, as I said, we have more than 60 roles here. So some of the examples of inbuilt role, for example, the owner role, which allows the management of resources and also the management of resource access. So if you see the contributor role, this allows the management of resources, but it does not have the ability to control resource access or permission, in other words. And then we have the reader role. It is like the name implies, provides whoever has been assigned it read-only access. And remember that applies to a scope, whether it's a management group that contains multiple subscription, or whether it's been assigned at the scope level of subscription, maybe at the resource group, or even at the individual resource. Then we have got some more resource specific type of role. So for example, if I go down, we have the storage account and storage blob data reader allows the reader of storage blob data, and it is specific to a storage account. And the virtual machine contributor role allows the management but not the access to virtual machine. So if I want to allow someone to be owner of this account, so I will select an owner, and to whom I want to give this role. So I can choose the individual user here, but I don't have any user, otherwise you will see the list of individual user here. Or for example, I want to allow, let's say, the data factory, and you can see I have another data factory with the name df108. I can choose this data factory, and then I can click on save, and this will give data factory 108 to allow using my storage account data lake gen 2. To an ACL. So now here I have opened my storage explorer as well as my portal together, and I have selected here the access control, which is to assign role-based access control. And in my blob container, I'm talking about the manage access here. So the point is, so basically, if you're wondering what happens if you use both of them. For example, what if you assign the contributor role to blob for a container and then configured an ACL to give no permission to Bob for a folder? Would Bob have access to that folder or not? Well, Bob would still have full access to that folder because an ACL can't take permissions away from a role. You can use an ACL to add permissions though. For example, if you assign the reader role to a Bob and then configured an ACL to give him write permission to a folder, then he would have a write permission to that folder. So I hope I conveyed my point that the ACL cannot take away permission from the role. However, ACL can add more permissions to the role. Thank you. Now we all know one of the biggest advantages of the internet in the cloud is that global accessibility. That accessibility causes you a bit of stress though when you know precisely and exclusively who you want to have access to your data. Every object in your storage account has a URL endpoint, and requests can be made to it from anywhere in the world. And they might come from known IP address ranges, like maybe your office building or that of your partners. Or they might come from another application or a virtual machine in Azure that may be part of a virtual network. Or they can come from anywhere else. So the firewall and virtual networks feature of Azure storage allow you to lock down your storage account very strictly by limited access to certain networks or IP address ranges. So I'm in my portal now, and on the left hand side menu, if you go a little bit down, under settings you can see firewall and virtual network. So you can click here and you can see that by default access to a storage account is open to all networks. But this doesn't mean that just anyone's allowed in. You still have to authenticate and be authorized to access resources. But that holds true even after network rules have been established. You might have a perfectly valid SAS token, but if you attempt to make a request from an IP address that's been restricted using network rules, then you are out of luck. So to configure rules, you select networks, and the rest of the page opens up with a bunch of configuration options. You can see virtual network settings here, firewall settings here, and some of the exceptions here. So virtual networks or VNet integration will disable access from the internet and only allow access from the Azure virtual networks that we configure here. You can also specify subnets within the virtual networks that you choose. You can configure up to 100 of these, so hopefully that's enough for you. Then you can use the next section to configure the firewalls. So in the section below on the firewall, you can specify the IP address or range of IP address which should be allowed to have access to storage account. So basically you can add a specific IP address here, or you can use the CIDR notation, which can store up to 100 IP network rules for each storage account. You can add a range here for a public IP addresses in your organization. So for example, if you're using express route to connect to your network to Azure, it's done via Azure public peering. And you can also specify IP address of the express road circuit. So basically with firewalls, we can allow certain IP address ranges, and with the virtual network, we can allow certain Azure virtual networks. All other requests will be denied. And this is a very strong security measure. And finally, there are few sensible exceptions you can make for the restrictions imposed by your configuration by enabling trusted Microsoft service to access this storage account for things like Dev Test Labs or Azure Event Grid and Azure networking. And there's also a setting here for allowing read access to logging and metrics from any network. That's needed to allow service like log analytics to access the data in your storage account. I hope this is clear to you. Thank you. Build-in data integrity checks that help mitigate network errors that can affect the integrity of your data. Client-side encryption is built into the .NET and Java storage client libraries, and they use Key Vault APIs to make it easier to implement. You can generate and manage your own encryption keys on the application side, or use keys generated by the storage client libraries, or let Key Vault generate the keys. And then you can store the keys locally or transfer them to the Key Vault. and use it to grant access to Azure Active Directory users and applications. For many organizations, data encryption at rest is a mandatory requirement for data privacy and compliance. And this is especially true when dealing with the increased level of data sensitivity. Every Azure storage account has encryption data at rest enabled by default. In fact, even if you want, you cannot disable it. This is called Storage Service Encryption, or SSE, and it transparently encrypts the data when writing to Azure storage and decrypt it again before the data is read. So you will get the encryption without having to modify your code or add code in your application. And it is free. There is no charge for SSE, and it applies to standard and premium performance tier, and it is enabled for all the services: blob service, file, table, or queue. And it is enabled for you whether you use the resource manager deployment model or the classic deployment model. The encryption uses 256-bit AES encryption, which is one of the strongest block cipher available. And there is also another option to use your own encryption key to encrypt blobs and files in Azure storage. Alright, so I am once again in my storage account, and on the left hand side menu I will once again scroll down under the setting, encryption, and this is the setting where encryption at rest is defined. And you can see that we do not have any option to disable this setting here. Only option we have whether you want to use a Microsoft managed key or you want to use a custom managed key. And you can see by default SSE uses encryption keys managed by Microsoft, in which case Microsoft generates the key and handles their secure storage, and also rotates the key regularly on a schedule which only Microsoft knows. But if you like to have more control over those keys, you can choose the custom managed key, and you can use this key vault to store and manage your own encryption key. And that's all with the encryption at rest. Thank you. So I'm once again in my storage account, and once again if I scroll down here and under settings I can see advanced security. This is advanced threat protection. Advanced threat protection provides an extra layer of security for Azure storage, and this detects any unusual or possible harmful attempts to access or manipulate storage account. So when system detect any anomalies, any unusual activity, system send alert, possibly through email. So let me show you an example of alert. So alert looks like this. It has the name of the storage account, storage type, and all other details from which IP address it is coming from. And then here is the potential cause of the alert, that why this alert has been generated, and what kind of investigating steps we can perform, and what kind of remediation steps or recommendation steps Microsoft suggests to follow. So let me go back to my portal. So you can see as of now I do not have any recommendation and security alerts, but this is a very simple interface. You don't need a security expert or some kind of security monitoring system to enable this. Let me go into another storage account and I can show you how easy it is to enable this. So right now I'm in my another storage account, and if I go down here I can see advanced security, and all I have to do is to just click here, enable advanced threat protection, and that's it. The system will monitor and you can take advantage of it. And another thing to notice is that it is not free. So first 30 days are free, but after that it will cost you $0.02 for 10,000 transaction but I think it is worth to spend this amount in your production system. I hope you find it helpful. Thank you. The Azure Activity Log is considered to be a control plane or management log. So its purpose is to provide insight into the operations performed on the resource itself. In this case, the storage account. So this includes things like modifying user role assignments to the storage account, or regenerating storage account keys, or changing settings like requiring HTTPS to access the data plane, or modifying tags attached to the storage account. And as I said, it record operations on the resource, not by the resource. For example, it does not include logging of activities that happens against the data plane, like uploading or deleting the blob, tables or queues. That's not going to record by activity log. Those are considered a diagnostic logs, not management log. The Azure Activity Log is a subscription-wide log, meaning that all the events that take place within the subscription for resources get logged to the Azure Activity Log. The Activity Log actually includes a few different categories of events. The one I mentioned earlier are administrative events, which document all of the changes to the resource, like who made the change, when was the change made, and it also includes any changes to the RBAC or role-based access control assignments to the resources. But the activity log also captures service health events, like incidents in the Azure region, or maintenance events, or security events, or any other information events. Those type of events also appear if you have resources in the subscription that would be impacted by the event. And for those resources that supports the auto scaling, the auto scale events are also recorded in the activity log. Like for the app service, for example, if the number of VMs are auto scaled due to a metric reaching a threshold, it will show up in the activity log. Activity logs also record the recommendations by Azure Advisor. So Azure Advisor basically analyzes your resource configuration and usage telemetry and recommends way to improve the cost effectiveness or the performance and availability, or in fact the security of your resource. So all those recommendations also get logged by activity log. Azure Security Center generates the security alerts, and these alerts are also logged in activity log. And if you have configured any alert in your storage account, those alerts are also logged into Azure Activity Log. So for example, let's say you have set up an alert that if the key change, and you will get an alert for like by email or by text message. So when you see the activity log, you will see this alert also there. Now you can view the activity log data in the portal, but by using Diagnostic Settings, you can also send activity log data to different destinations. You can export the data to a storage account or to event hubs, where you could pick up the data for storing in your own solution. And you can also send the activity log data to a log analytics workspace for more advanced querying. You can query the activity logs within the portal, or using PowerShell, or using Azure CLI or the REST API. And as I mentioned above, you can send the log data to a log analytics workspace, which provides the central place to view log data along with the query language. Now earlier it was not so easy to send this data to Log Analytics, but now from within the portal you can configure and send this data to Log Analytics for further analysis. So now let's look at how to view activity log data and how to configure this activity log data to send to Log Analytics workspace. Hello friends, welcome back. And in this lesson, we will explore activity log. So in your search bar, let's search for activity log, and I can see activity log here. So let me click here. And here I can see all the events or all the logs operation performed on my resources. So you can see we have an operation name here, what kind of operation performed, what was the result of the operation, status, what time it was performed, and event initiated by who performed this operation. And if you want, you can add a filter here to look at logs for a particular resource. So for example, I can choose resource here, and let me choose my storage account. So now I can see all the events or all the logs from my storage account, and I can change my time span here. Instead of looking at for last 6 hours, let me look at for last 1 month, and I can see all my events here. Now instead of looking at event log for subscription level and then filter for the resource, I can directly go to my resource. For example, in home page I have a shortcut for my storage account here. So let me go here, and in this storage account on the left hand side menu you can see activity log, and when I click here, the filter for resource will be applied directly here because I'm accessing this from inside my storage account. And once again you have the similar data here. So let me change time spent to last 1 month here, and I can see logs for last 1 month. Let me collapse this to create a little bit more space here, and you can see events here. For example, list storage account key or regenerated storage account key. So let me open this. So let's look at who regenerated this account key, and operation name was regenerated, but it was initiated by me at this time, but I don't have any information to see which key was regenerated. So I can go into the JSON file to look at the more details, and if you look this JSON file, you can see the key 1 was regenerated. Similarly, sometimes you can also go into change history to look at more details. We don't have change history in this case, but looking at JSON or change history can give you more detail than summary. Similarly, you can look at other operations performed on resources. For example, list storage keys, or you can see here update the advanced threat protection setting. So once again, this is the handy page to quickly come and look around what kind of operations are getting performed on my storage account. And if I want, I can filter it down further. For example, I can add filter, and I can look for particular operation if I'm searching for, and here's the list of all kind of operations, and I can filter it down to look at particular event or log I'm looking for. Also, there's other option to export all these logs into Log Analytics, and we can have that setting here in Diagnostic Settings. So let's go into Diagnostic Settings, and I can add Diagnostic Setting here, and I can give some name here, and here I can choose what kind of log I want to export. So let me choose all the logs: administrative, security, service health, alerts, recommendation, policy, auto scale, and resource health. So we can filter down here, or we can choose all the logs, and now where we want to send these logs. And we have 3 options. Either we can send to Log Analytics, and we can choose our log analytics account here. And also we can send it to some storage account for maybe some long-term storage purpose, and we can configure our storage account here, or we can also send it to Event Hub. So you might have your own security information and management tool, or SIME or SIEM, and you want to pick up these events and store them within that tool, perhaps maybe on premises. So Event Hubs enable a situation like that. So let me configure this to send to log analytics as of now. So let me save this here, and now I can go back to my storage account. So let's open the log analytics, and where we will see the table generated and where we can explore and analyze these activity logs. So let's search for log analytics here, log analytics workspace, and here you go inside the workspace, and let me collapse this to create a little bit more space here, and go into logs, and here you can see all the tables, and one of the table is Azure Activity, and you can open this and you can see all the columns available within this table, and you can query the data inside this table. And if you can see, we have a little icon here which says the preview data. So let me click here, and it is showing the rows inside this activity table, and I can click on see in query editor, and you can see that it has ran this query, Azure Activity, where the time generated is greater than 24 hours and limit for 10. And here we can see all the events generated in last 24 hours. And this is how you can look at the alerts or logs inside the activity log, and if required you can export to log analytics, and you can query and analyze these logs further. Thank you. In this lesson, I want to talk about metrics. Metrics are kind of numerical values that describe an aspect of a system at a particular point in time. They get collected at a regular interval with a timestamp, name, and a value. So in terms of Azure storage, some of the metrics collected are the amount of capacity being used by the individual blob, file, table, and queue services. And there is another kind of metrics called transaction metrics, and transaction metrics about the availability of the services, the number of transactions, and the amount of time those transactions take within the Azure, and taking into account the total end-to-end latency with client calling Azure storage. And you can also set alert on these metrics, so you get notified when they pass a threshold that you define. And this lets you proactively monitor your resources and investigate problem before user report them. Now let's talk about where metrics store data. So metrics are stored in a time series database that optimized for analyzing time-stamped data. Each set of metrics values contain the time the value was collected, the resource it was collected from, the category, metrics name, and the value. There can also be other attributes in the form of name-value pairs, and these are called the multi-dimensional metrics. Now let's talk about the speed of this metrics data it was collected. So most of the data collected by Azure Monitor is collected every minute. The speed of collection and alerting allow you to almost near real-time monitoring of a system, and it stores data for almost 93 days. So you can go back up to 93 days to view metric data. And if you need to store data for more than 93 days, then it is also possible to store metrics for some resources longer by creating a diagnostic settings that routes the data to Azure storage, and we will see all this in the demo. And as I mentioned that you can set up alert on the metrics data, once you established a baseline for your application through monitoring the running application for a while, you can set up an alert to notify you when metrics go above the threshold that you define, like the time it should take for a transaction to complete, or maybe, for example, if the amount of storage being used approaching the maximum of the storage account, you can set up an alert. Metrics can be accessed within the Azure portal, either right from within your storage account, or from your Azure Monitor service, or from the APIs via REST endpoints. There's a .NET SDK, and there are commands to read the Azure Monitor data from PowerShell or the .NET CLI. You can also stream metrics data to event hubs. And again, we'll see all that in the demo. Hello friends, welcome back. In this demo, we will see how we can monitor our Azure storage service through metrics. And right now I'm in my home page of my portal, and you can see I have a shortcut here for the metrics. Or if you like, you can also search metrics here. Metrics is a separate service within Azure to monitor all the different resources. And you can see this right now I am inside the metrics, and the first thing I'm supposed to do is to choose a resources which I want to monitor. So I can see all my resource groups here, and one of the resource group is RG recording, and within that I want to, let's say, monitor my this storage account Gen2 storage 1088. So I can choose it, and then I can choose the namespace and different kind of metrics, and I can see graphs here. Now instead of accessing metrics service directly, we can access the monitor service. Now this monitor service is kind of central location to monitor all the resources, and this is a unified service. You can see we have activity log, alerts, metrics, logs, and all different kind of monitoring services combined together within this Azure monitor. And of course we also have metrics here. So this is a one single place where you can come and utilize different services from Azure and monitor all of your resources. So I can access metrics from here also. And if you see, this is again, I have the same interface where I'm supposed to scope down or choose my resource which I want to monitor. Or we can directly go to our resource. So for example, I'm going back to home, and here I have a shortcut for my storage account. So let me access my storage account from here. And if you scroll down and navigate to your monitoring section, I can access metrics right from here. So let me select this, and you can see, since I am accessing this metrics from inside my storage account, I don't have to choose the scope. It is selected by default. And then if you look into the namespace, I have option to select either the full account, which is a kind of combination of blob, file, queue, and table, or I can access the individual storage service here. So let me select the account first, and then in the metrics section, you can see we have two main categories. One is the capacity and one is the transaction. So the capacity records the amount of storage used by the entire storage account. In this case, which is a sum of capacity used by blob, table, file, and queue storage. So let me choose this, and you can see that my capacity is almost constant in last 24 hours. So let me change the time span here. So instead of last 24 hours, let me choose last 7 days and click on apply. It seems like I added few files here and then I removed those files, but more or less I have a constant capacity use here. Or if you want, you can choose a separate account here. For example, I can use the blob here, and you can see we have a different capacity metrics for the blob. We have the capacity, which means the storage, and we have the container count, number of containers, and number of blob counts, and the capacity used by the index. So once again, let me choose the capacity here, and you can see I have more or less the same graph here. Similarly, you can choose any other storage service here, and you can use the capacity graphs here. Next, we have the transaction, and transaction metrics record the number of requests made to the storage service or to specified API operation within the service. So this includes many matrices. For example, we have the availability. So for how long my storage account was available, or it also records the failed API operations. Or you can see we have egress and ingress and a number of transactions. And we also have the performance matrices here, which include the success end-to-end latency and success server latency. So for success server latency, metrics are available to monitor the time used to process a successful request by Azure storage. This value does not include network latency. It's just the time the operation took within Azure. But there is also a matrix called E2E or end-to-end latency, and this matrix includes the processing time within the Azure storage to read the request, to process it, to send it back, and then receive the acknowledge from the caller. So it records the end-to-end latency. So these two matrices, success server latency and success end-to-end latency, can help you determine if a reported issue relates to the server or the network communication. So for example, let me select the success end-to-end latency here, and in last 7 days I can see the graph here, and I also have option to further filter out these graphs. For example, I can add filter here, and let's say I want to see information only for the API name, let's say list container. So I want to see the latency related to list container call in last 7 days. Similarly, I have option to filter down for particular authentication or for particular geotype. So geotype dimension is to see whether the transaction were from the primary or secondary cluster when using read access geo redundant storage. I only have primary, so I won't be able to filter it, but I hope you understand my point. Or if you want, you can split this graph. For example, I can apply splitting, and let's say I want to split this for authentication type, and you can see I have a different authentication through SaaS or OAuth or account key, and I can see different graphs for different kinds of authentication here. So for example, if I take my mouse over to account key graph highlighted here. So this is the latency, end-to-end latency for my authentication through account key. Or if I take my mouse over to SaaS here, shared access signature, I can see this red line here, which is related to latency, end-to-end latency for authentication through SaaS. So basically, splitting controls whether the chart displays a separate lines for each value of a dimension or aggregate the value into a single line. And you have option here to show different kind of graphs. So instead of line, you can show, let's say, area graph here or the scattered chart here. I think line graph looks much better here. Or if you want, you also have option to create an alert based on this graph. So you can mention that if let's say latency is above this particular threshold, let me get an alert through my email or my text message on my mobile, and then I can come here and troubleshoot it further. So you can see what a wonderful tool it is. If I have a problem and if it's around the performance, we can come here and take a look at the counters. You can see if I'm seeing maybe some kind of bad latency values. If I'm seeing availability challenges, I can look at the ingress or egress. what are they showing me about the way my store account is actually being used. So it's a wonderful tool to troubleshoot and monitor our storage services. In fact, any resource within the Azure. Thank you. Hello friends, welcome back. And in this demo, we will see the monitoring through Insight Graph. So once again, I'm in my storage account, and in the menu, if you scroll down a little bit, under the monitoring section, you can see brand new insights. So this is the new monitoring tool to show some ready-made graphs about the various aspects of how your storage account is operating. And you can see that this is still in preview. So we can change the time here. So let me choose last 7 days. And you can see we have different sections here to see different graphs like failure, performance, availability, and capacity. But right within the overview, you can see the most essential information in terms of availability, number of transactions, and different latencies. So availability is of course the percentage of availability of a storage service. So in last 7 days, it was 100%, which is good. And transaction means the number of requests made to the storage service in last 7 days. Success E2E latency or end-to-end latency measures the interval from when Azure Storage receives the first packet of the request until the storage receives a client acknowledgement on the last package of the response. So basically this value includes the required processing time within storage to read the request, to process the request, to send the response, and then to receive back the acknowledgement from the client. So this is end-to-end latency. And if you see the success server latency, basically this is the time to process the request. So this is the time between receiving the last packet from the request and until the first packet of the response is returned from the Azure storage. So in simplified terms, you can say that success end-to-end latency also include the network latency, and success server latency only include the time to process within the Azure service. So if we scroll down here, we can see that transactions are splitted according to different storage type here and according to different APIs here. So you can see that read file API has the highest number of transactions here. And if I scroll down further, I can see the availability, which is 100% for all my accounts, which is good. And here I can see the used capacity, and the highest capacity is for the blob, you can see here. And the second highest is the green line, which is the table capacity here. So you can see the capacity for your individual storage type here. And let's scroll down further and see here on the left hand side the latency for E2E and for server side latency. And if you see the graph, you can see here on 7th, I can see my E2E latency was higher than the server latency. So it seems like there was some little millisecond of network latency on 7th May. So this is how these graphs are so helpful to troubleshoot, to figure out whether the latency or the issue was at the server side or at the network side. Similarly, we can see here the graph for ingress and egress. So let me scroll up once again and go to different sections here. So you see we have different workbook here, and right now we are in the overview. So let's go into the failure, and the failure workbook shows us the client side error. So out of total so many transactions, almost all of them were success, and we had 38 errors at the client side, and 9 is the authorization error. And if we scroll down below, we can see these figures in the graph. And here further, these transactions splitted into different APIs named, so we can exactly see that which API was causing the most of the error. Or in the right hand side, we can see that what was the response time which was causing most of the errors. So let's go to the performance here. And once again, the performance workbook gives us the roll-up for end-to-end latency versus server latency. So we can tell if the network is causing an issue, and we can also see a breakdown of latency by specific API. So if we scroll down here, we can see which API was causing most of the latency. And we can see here that the get blob service properties, this API was getting most of the latency. And similarly, we have different graph for the table, files, and queues here. And then we have the availability, and availability workbook actually includes the state of the Azure storage service in the region to know if there's something going on outside of your control. Then there's some timeline information. So as of now, you can see that all my services are 100%. But if there's some issue at the Azure infrastructure end, we can look at those issues also here. And of course, you can see the availability of individual APIs here. So let me scroll up once again and go to the capacity here. And the capacity workbook shows a breakdown for the different services, including the number of blobs and files and queues, and the capacity being used over time. So in the capacity workbook, we can look at the capacity used by the total account, or how it is break down by different services. For example, we can look at the blob services using almost 32 megabyte here, and I do not have anything for the file or queue, and the table is using a very small space here. And if we scroll down below, we can see that these figures in terms of the graph. And if you remember, this is the same graph we looked at in the first overview page, where it is splitted according to different service here, the storage and the unit. So you can see that we can do the comprehensive monitoring using this Insight workbook here. And if required, we can also tag these metrics to our dashboard right from here. So basically, we can create our own graphs, we can add queries, we can add metrics, we can publish it. And we also have option here to share these metrics with our managers or different colleagues. So although these metrics are pre-built, but you can edit them to your needs, and you can modify these matrices, and even you can set the threshold that causes some visualizations to show in different colors, and you can modify the colors also. So basically, you can customize these workbook right from here, and you can edit it, and you can change these values from here. And after making these changes, you can save it back. Also, as I said, these are pre-built workbook, so you can create a different workbook right from here, and we have a shortcut for that. So if you click on gallery, we will go to the workbook. You can see it right here. And as of now, we are looking at these 5 workbooks in the Insight: overview, failure, performance, availability, and capacity. But you can create the new workbook here. And as I said, you can use metrics and queries of your choice, and you can give colors of your choice, and you can create visualizations for your need. So Insight for storage is a powerful new feature that helps us visualize the overall health of our storage account. Thank you. Hello friends, welcome back. And in this lesson, we will see how to create alerts within Azure. So alerts is also available as a separate service within Azure. So you can search for alerts and go inside the alert service. And as I told you in previous lessons, that we also have a unified central service to monitor all the resources, and alert service is also part of monitor service. Or also you can go back to your storage account, and from within a storage account, if you scroll down to the monitoring section, you can see the alerts right from here. So before we move forward, let's quickly understand why we need alert. So Azure services can produce large amount of data in terms of metrics and logs. And it's very challenging to go to the metrics and the logs every time and try to monitor if there's something's wrong. Instead of that, Alert provides the ability to define the signals that as an organization you need to know about and proactively act on it. So for example, you can create an alert if there is some kind of performance issue of resource consumption, let's say. Or you can define alert, let's say, for the cost or budget thresholds. Or you can set an alert for the security events or some kind of service health or availability. So the goal of the alert is to know about something before it impacts our service. So right now I'm in the alert section. So let me collapse this to get a little bit more space here. And I can create a new alert here. And once again, since I'm accessing the alert service from within the storage account, I don't have to select the scope here. My storage account already selected here. So right now this storage account will be the scope of this alert. And then we need to define the conditions here. So click on select condition. And here we need to select the signal for the alert. So we have two types of signal. Either we can use the metric signal like the capacity and transactions and all. And we can use the log kind of signals like administrative operations or list storage account keys and all. So let me go back to the metrics one. And let's say we want to select a signal as a usage capacity. And it is showing us the graph for the usage capacity in last 6 hours. And of course you can change the timeline here. And if we scroll down further here, you can see our current usage capacity here. And here we need to define the signal value. For example, whenever the usage capacity is greater than the average of, let's say, 1 GB. So this is in bytes. So let's say 3, 4, 5, 6, 7, 8, 9. So I think it's 1 GB. But whatever it is, my point is, if the capacity is greater than the average of these bytes, and what should be the frequency to evaluate this? Maybe let's say every 5 minutes, Azure will go and check the capacity and will take the average of 1 hour of data. So period, let it be 1 hour. And let's click on done here. So right now within this storage account, if the capacity is greater than 1 GB, then what? Then this action group we will define here. So basically in action groups, enable set of action to be defined that can be used across the alerting mechanism. So if we define some action group here, we can use for all the alerts. So let's go inside it and let's click on select action group here. And I do not have any action group right now. So let me create one. And here we need to give the group name. So let's say email. Short name can also be email. And my subscription is right here. And it is going to create a new resource group. You can see here to be created. But I don't want to create a new resource group. I want to keep everything in RG recording here. And then here we need to choose what kind of action type we want. So email is very popular here. Something occur, we send an email to the group responsible for that service, or maybe to a management chain, and we can text people, we can make phone calls. And here we also have option for ITSM, IT Service Management System. So we can integrate our alert with ITSM, and this raises a ticket automatically, which would then assign to the group. And this can be useful not just for notification, but then actually tracking service level agreement as part of resolution of the problem. And sometimes there are things that may be automatically resolved. Sometimes we know that if this kind of problem occur, we need to perform these tasks, and we know that this can fix the problem. So no one has to get out of bed to solve that issue. So another common type of action and response to an alert is an automation. And this could be a automation runbook. This could be a PowerShell. It could be a Python. It could be one of the serverless technologies like logic apps. Logic apps are great for providing integration with a large number of different services that I utilize through a graphical offering system where I have this flow of the execution. And then I can use the Azure function. Another serverless technology. This supports a huge number of languages, but as an administrator, I might want to use PowerShell, or I just want to hook into something else. I can use a webhook. There's some RESTful interface. I can trigger that, and I might use a combination of these things. So for example, I can choose email here, and I can add another action type here. And basically I can create a set of actions within this action group. And so I might use a combination of these things. So let me choose my action type here. Let me edit details once again. And I want to set an email, and let me give my email ID here. Click on OK. And here I need to give name for the action. So it looks good. So let's click on OK here. So we have created an action group. So as of now, in this resource, if my capacity goes above 1 gigabyte, then it will send me email alert. And let's go down once again. And here we need to define the name of the rule. So I can just say send email here, and what kind of severity it is. So right now it is 3, and which looks good. And I want to create a rule upon creation. So let's create a rule here. All right, it seems like my rule is created. So I can go inside the manage alert rules to look at my existing rules, and if I need to change something here. So I can see my send email rule here. If I want, I can go inside. And if I want, I can change any of these settings here. So I don't have to continuously monitor the matrix here for my capacity. Anytime my capacity goes above 1 GB, and I will get an email alert, and I can go and look at whether there's a need to increase the capacity of my storage account. Thank you. Hello friends, in this lesson we want to talk about diagnostic settings. Diagnostic setting logs different events of your Azure service. So let's first talk about what is log. Logs are events that occur within a system. So they are typically not regular observations. They get generated based on something happening. They can contain different types of data, numeric or text data, and they help you track down the cause of issue, like errors in applications or issues you find from proactive monitoring of matrices in your Azure monitor. So these logs are very helpful in tracking down and troubleshooting the issue. Now most of the services in Azure send log to Log Analytics to save and for further analysis. And not just Azure, but in fact very much any kind of service, any kind of source can send data to Log Analytics. So Log Analytics is like a central location to not only store these logs, but also do further analytics using a rich query language. It's called a Kusto query language. So as I said, Log Analytics data can come from a variety of sources. For example, Azure Active Directory audit logs or data from activity logs can be sent to Log Analytics. And this log data can come from diagnostic settings on individual resources in Azure. And server logs can be sent from Azure App Services, as well as from agents installed on infrastructure as a service virtual machines. You can even send log data from on-premises agents using System Center Operation Manager. Applications can send detailed data about requests and exceptions, and trace data, data from availability test, and all this app related data comes from application insights. And you can write custom data to Log Analytics workspace using the REST API or using a connector in an Azure Logic app. Now, once we have this data in Log Analytics workspace, we can do analysis of data. See, metrics are lightweight and maybe ideal for fast detection of issues, but logs are for deep analysis. And as I said, you can analyze them in Log Analytics workspace using the query language called Kusto query language. And within Log Analytics, you can perform visualization with the chart, and you can also set an alert on log data to get notified when certain kind of event occur within your resources. Now, as I explained earlier, most of the services directly write logs to Log Analytics, but there are still some services who do not write logs directly to Log Analytics, and Azure Storage is one of those services. So Azure Storage still write logs to the folder called logs in container within the storage account, and these logs can be moved to Log Analytics manually if required. So storage analytics can log all the operations that occur against your storage account. It logs both the successful request and the failed one, and you can see the details of read, write, and delete operations against your blob table and queues, and see the reasons for failed requests like timeout and authorization errors. So all this information can help you diagnose and troubleshoot issue. Every time an operation occurs, there is a lot of information stored. The type of operation is logged, like the listing of blobs and containers, creating blobs, reading service properties, creating tables and entities, deleting entities, and inserting queue messages. With each operation, the success or failure of the operation is logged, along with the key of the storage object the client was accessing and the HTTP status code returned. The start time of the operation is logged, along with the amount of time it took the server to complete the operation, and the amount of time that the end-to-end transaction took with the caller making the request. And this can help you determine if there is a latency within the storage service or with the network connection. If there is a latency within the storage service, you can check the logs for failed requests due to timeouts or authorization errors and information on other types of errors. Or you can see if the request was anonymous or how request was authenticated, whether the caller used the shared access signature or storage account key or an OAuth token. So you can audit whether or not your access policies are being followed by application and administrators. There's information about the caller also, like the IP address of the caller and the type of the client that was used, like browser information or whether Microsoft Storage Explorer or AZ copy was used. So you can use log data to determine how a client updated an object and who deleted a specific object. There's also information you can use to correlate multiple operations for the same request, and then identify send from the clients in a request header that can be used to correlate server logs with the client-side logs. Each server operation sends a different ID from the server back to the client in a response header also. So if you were to show that ID when error occur, you can search through the logs for the server ID of the operation. So when operation occurs, Azure Storage Analytics write blocks to the blob, but it can take up an hour for the log to be available because storage service needs to flush the log writer and commit the blocks in order to the blob to appear. When you are searching for log entries, you need to keep this delay in mind, especially if you're trying to correlate timestamps from client-side logs created with the storage client library. You should either search the server-side log files created 15 minutes before or after the timestamp when you are looking for. Or a more accurate way is to search the server-side logs by filtering on the blob metadata, because the metadata will contain the time range for the first and the last operations in each particular log files. Keep in mind that log data is still a data within your storage account, but you are being charged for storing it, as well as requests to create blobs for logging and bandwidth charges when logs are downloaded from Azure storage. So basically it's good to set up a reasonable retention policy for the data. Also, Storage Analytics has a 20 terabyte limit on the amount of data stored, and that limit is independent of the total limit of your storage account. Now let's look at the demo to see how to enable Storage Analytics within Azure portal. Thank you. Hello friends, in this demo we will see how to use diagnostic settings for monitoring our storage account. So once again, I'm into my storage account, and on the left hand side in the menu, if I scroll down under monitoring classic, I can see the diagnostic setting. Now you might have noticed here that alert and metrics, we already have the new version here, so we don't need to use the classic one. And the usage is nothing but to monitor our capacity, and you can see we have these graphs for capacity, and this we can access again through metrics or through insights also. But if you see diagnostic setting, we do not have the updated version here in the new monitoring section, so we are still very much depend on this classic version of diagnostic settings, at least for storage service. So let me go into diagnostic settings, and here we can configure our diagnostic settings, and you can see on the top you can on or off this diagnostic setting. I on it a few days back when I was thinking about to record this demo. So here you can see we have a separate section for all 4 services. We have blob properties and files and tables and queue, and we have to separately configure these storage services. And within each storage service, you will see that we have 2 different types of logging. One is for the metrics log here on the top, and below you can see logging, except the file properties. In the file properties, we do not have the logging, but we have it for table as well as for the queue also. So for some reason, it is not enabled for the file properties. So in the metrics, we have again 2 kind of metrics, hourly metrics or per minute metrics. So minute metrics is basically more granular version of the logging, and we can enable this setting here, and we can configure if we want to include the API metrics also. And here we can define that how long we want to retain this data, and we can retain it up to 365 days, and for minimum 1 days. I think 7 is the default. But the point to remember here is that this storage is not free. You are going to be charged for this storage. So you want to make sure that you use this retention property as per your need. And another point I want to remind you once again is that these logs are nothing but just a blob in your container. So if required, you can have the retention policy of maybe longer, but if you feel that it is going to charge, you can move these blocks basically into a cheaper storage and save some money out there. And there's no difference in minute metrics. We have the same options available here. And if we go below in the logging section, we can see we have 2 versions of logging, version 1 and version 2. And the only difference is that the version 2 adds field for logging information about request to a blob and queue services that are authorized with an OAuth 2.0 token. So all fields of version 1 are included in version 2. So let me choose 2 here, and once again I can configure here whether I want to log the read operation and the write operation and the delete operation. And here once again I define how long I want to retain this data. So as I said, all this logging save in the container. So let's go into the container and see where these files are saved. So let me scroll up here and go to the containers. Yes, I will disregard the changes I just made here. But I do not see any container here. This is because this container is hidden. We cannot access this container from the portal. To access the log container, we'll have to go to the Storage Explorer. So let me go to my Storage Explorer and try to find the log container. Alright, so now I'm in my Storage Explorer, and within my subscription, I can navigate to my storage accounts and to my storage account Gen2 Storage 1088. And within that blob containers, I can see the logs, and this is where our logs are saved. So if I go inside the blob, this is in the format of year, month, date, and hour. So this is the year 2020 and 5th month and 11th and 13th. These are two dates. So let's look at what we produced today. And this is the hour, 1900 hour and 201 hour. So let me see what is inside that. And here is the log file. And these log files are just text files though. And the properties that are stored in each log entries within the file are separated by semicolons with each log entry ending with new line character. So if required, in fact, you can download this log file from here, and then you can import this data into the Excel file and can do the further analysis. Also, as I said earlier, these are just like a blob, and if you want, you can delete them yourself, or if you want, you can just move them using any of Azure tool like Data Factory or any other tool to some other cheaper storage. Also, this is the logging data, and if you want to see the metrics data, I can come here into the table section, and you can see here we have these tables generated to store the metrics data. And here we can see all the details related to capacity, and here we have the R matrix. If you see from here till here, we have all these tables generated to record the metrics for hours, and all below tables are generated to record the metrics for minutes. And you might have already noticed that we have a separate table for the blob, for file, for queue, and for table, and 4 tables for primary and 4 tables below for secondary. And before I close this demo, I want to show you one more thing. Let's go back to the log and let's navigate back to the storage file, the log files we just saw a few minutes back. And for example, here we have a file, and if we look into the properties of this file, and here you can see the metadata attached with this log file. So you can see that we have start time here and end time of the log. So we can see the range from what time to what time this file was written, which can give us the idea of the time range recorded in this file. And we can see what kind of log type it is, whether it's a read or write or delete or any combination of those. And here we can see the log version 1.0. So sometimes looking at these metadata information may also be helpful when you are troubleshooting your issues. So as of now, you may have to analyze these logs manually, or you may write some application, some code to read these logs and convert into some kind of valuable information. Or other option you have is to move these logs into log analytics. So as I said earlier, there is no direct way to do it right now, but you can convert these logs into the JSON files, and there's so many tools available which can easily help you to convert these files into JSON, and then load these files into log analytics. And in log analytics, we have query support. We can use a Kusto query, and using that query, we can do the deep analysis of these logs. We can create report, we can create chart, and different kind of visualizations there. So I hope now you are a little bit more familiar with the diagnostic settings and how you can log your storage account for doing further monitoring. Thank you. In this lesson, I want to explore the Azure Data Lake Storage Gen 2 tuning. Now, as you know, Azure Data Lake Storage is built on top of blob storage, and it is designed for big data analytics. So it is designed in a way to give very good throughput and performance for big data processing. But there are still few things we can keep in mind while working with data lake to get the best performance out of it. So the first one is data ingestion consideration. When you are transferring large amount of data from your local infrastructure to Azure cloud, there are three potential bottlenecks. The first is storage hardware. Ideally, your local data should be on SSDs rather than spinning disk, and on storage arrays rather than individual disks. So you want to make sure that your local storage hardware is not the cause for bottleneck. And the network interface card on your local machine should be as fast as possible. So you should have a high-speed internal network. And the third and the most important one is the network connection between your local infrastructure and Azure cloud. It should be very fast, and it's a major bottleneck generally. And you can consider using a dedicated link with the Azure Express route to avoid this bottleneck. And the next is the parallel read and write. Data Lake really is tuned for big data. We think of a petabyte of scale, super high throughput. Now, when I use this, I really want to optimize the throughput available with the data lake by making sure that I am performing parallel read and writes. I don't want to just write using one thread or read using one thread. I want lots of parallel threads going on so I can really take advantage of the throughput of data lake. And that's going to also depend on the tool I'm going to use with data lake. For example, sometimes like Azure Data Factory, there is a parallel copy setting. And I want to make sure that I'm utilizing that setting to ensure that I'm really maximizing that available throughput. So when I have data in the data lake, I'm going to use different systems to work with my data lake. So depends on those systems. Sometimes it matters that how I'm storing my data. What is the structure of my data? For example, what is the size of my files? How many number of files I have? So for example, let's say if I have file of greater than 100 GB, then there are some systems which struggle processing this big file. So I want to make sure that my file size is not too big. And at the same time, if I have so many files of the smaller size, let's say hundreds and thousands of files of very small size, then there are systems which have a per file overhead. So if you store your data as many small files, this can negatively affect your performance. So in general, it is better to organize your data in a file size between 256 megabyte to 100 gigabyte in size. Similarly, it is also important how I am naming my files. So it is recommended that we should have the folder structure, or in fact the file name, in the format of year, month and date. So for example, if I'm having some workload and system is trying to read the files between certain range, and if my files and folders are in this particular format, it will be easy for system to identify and read only required files, instead of reading all the files and trying to figure out the files that belong between that date range. So basically we want to have the name of the file in a way to depend on how we want to interact with the files. Another important point is that we want to make sure that data lake and other services that are interacting with data lake should be on the same region. So for example, if my data lake is in East US and my Databricks is in West US, this is going to add some latency. So we want to make sure that all these services belong to the same region. And the last point in the optimization is to make sure we understand that in data lake architecture, the storage and compute are separate. They are not combined, they are not united. They're not in the same cluster, which means there is going to be some latency. It may be just a millisecond, but if I have a very chatty workload with lots of round trips writing individual rows, I may see some performance degradation there in that case. So the better approach would be to batch my data. Instead of doing lot of 1 KB writes, I'll get a larger transaction, less round trips, better performance. And through that, I will also save some money because there's going to be a less storage transactions. Thank you. In this demo, we will calculate total number of people live in each kingdom postcode area. In the input file, there are 3 columns: a postcode, the number of people living in that postcode, and the name of the district in which the postcode resides. For those of you not familiar with United Kingdom's address system, a postcode is a unique identifier that represents a set of addresses for a particular area. Now we need to create a breakdown of how many people live in each postcode area, broken down by the first part of the postcode. For example, CT20 represents the area of Canterbury. So the totals of that CT20 postcode will be combined to provide the total number of people living in CT20. This is a small sample of data, so here the output will be 68. Similarly, output for NE25 area is 350. Our solution must be flexible to use upcoming file format changes. So our first challenge is to set up the data lake in Azure. I have logged in into my Azure portal to create the 2 accounts that will make up a data lake: the data lake store account and the data lake analytics accounts. As we discussed, the store account is where all of your data is stored and replicate. The analytics account is where you query the data in your data lake and generate those reports. Data lakes in Azure sit on top of HDFS, the Hadoop file system. This allows the massive scale and replication. Any data you load into a store account is split apart, spread across the nodes, and replicate 3 times for robustness. You are not losing any data here. Let's walk through the creation of a data lake. To create this account, click on All Services, then Everything, and search for Data Lake. You can see both Data Lake Storage and Data Lake Analytics options here. Alternatively, you can also click on Analytics category. On the right side, you can see a list of accounts you can create. And again, you can see both Data Lake Storage and Data Lake Analytics options. Click on Data Lake Storage, as this must exist before we create the Analytics account. Click on Add. You need to give this store a name. First, we need to select the unique name. Let's call it PopDen, population density. As you type, you will see the full qualified name populate underneath the text box. Subscription dropdown will have all your subscription options. If you have more than one subscription, choose the subscription you wish to use. Next, a resource group and location are required. A resource group is used to keep a collection of Azure assets together and is used to billing purpose, access control, or monitoring. The location dictates where your data will be created. You usually want to choose the geographic location, region, nearest to your business, nearest to the area where you work. Let's create a new resource group to keep everything together. I will call it as DLRG, Data Lake Resource Group. And let me choose Central US since this is the closest location to me. You can choose a payment plan on this screen. Paying upfront can be cheaper, but if you are new to the data lakes, it is probably best to pay as you go first and see how things work out for you. Unless you know your data volume, you can change the payment plan at the later date also. The final option allows you to set whether the data is encrypted or not. At this point, let's go with the default option. With everything specified, the Create button can be clicked, and after a few moments, the Data Lake Store account is created. It will take a few minutes. I'll pause here the video until then. The few minutes are up and the accounts have been created. Let's navigate to the resource group and find the DLRG group. Clicking on this, list the object belonging to the resource group, and there we can see the Data Lake Store account. Now we need to create an analytics account. Let's again click on all services and then analytics. We can see Data Lake Analytics here. The process is very similar to the one we just saw for the Data Lake Storage account. Let's give name popden as a population density and uses the resource group we created earlier, same resource group. This will ensure the analytics account is also held in the same location. We always want to have store an analytics account in the same location as it reduces the network traffic and also improve the performance. The key thing here now is to link the analytics account to the appropriate data lake store. Now this will list all the available data lake storage accounts. We can choose the data store account we just created, or we also have option to create the new storage account here on the fly. Let's select the storage account we just created and hit the create button to generate here the data lake analytics account. I'll be back in a moment once the account has been created. Wow, that didn't take that long. Let's see if our analytics account was successfully created. Navigate again to the resource group and click the DLRG group. There should be two items in there, and there we are, Data Lake Store and Data Lake Analytics account. Now we have everything we need to start creating Azure Data Lake solution. Thank you. Now we have set up our data lake account. We don't need to worry about it again unless we want to change some settings. Now we can work at the task at hand. To create the required report using a data lake, we need to upload the postcodes file to the data lake and then write a USQL script to extract and transform the data. Now we are again using the Azure portal. We can go to the resource group to find our data lake accounts. Or in the dashboard of portal, we can see resource group and all accounts. Alternatively, we can also use a search box to locate our data lake store account called popden. This is a brand new account, so it's all pretty boring at the moment. But the graphs to display a useful information once the store has been used for a while. There's a link to the Data Explorer available. This presents a File Explorer-like view of the content of the data lake store. It's empty at the moment. System folders are built into each data lake store. There are a few things that can be done here using the toolbar. The store can easily be traversed by clicking into the required folder. To go back to the previous folder, just click it on the path that appears. A new folder can be created to store new data, and the access button can be used to determine who has access to each folder. There's also an upload option, which we'll see in a moment. Let's create a folder to store her postcodes file. So click on the new folder option and calls her folder name postcodes. After clicking OK, the folder is created. Let's get into this new folder and hit the upload button. Upload screen allows user to upload multiple files at once. It is possible to do all of this kind of thing via PowerShell and Visual Studio also. You are not stuck with the Azure portal only interface. Let's choose the postcode file and uploads it. Is there a few seconds, and just like that, we have completed the E and L part of ELT, the extract and load. Now we need to handle the T part of ELT, that is transform, by writing a script to extract and transform the data, which we'll be looking into upcoming section. Thank you. In this video, we will write and understand our first uSQL script. To enter the script, let's navigate to the Data Lake Analytics account. Remember, that's where we write query to extract and transform data. The interface is fairly similar to the store account. We have various options on the left, which allow us to change settings for things like the firewall and pricing tier, with some buttons available in the toolbar along the top. There are some sample scripts you can take a look as if you are just starting out with uSQL. Let's hit the New Job button and write our own query, which displays the editor. The script will consist of three broad paths: the extraction, transformation, and the output. Let's begin with the extract statement. uSQL supports the notion of extractors represented in the language by the extract keyword. An extractor can be written for individual file types and formats. There are three built-in extractors for text, CSV, and tab delimited files. All of the columns in the file must initially be extracted. The columns can be reduced later in the script. C# data types are used to represent the type of each column, like int and string. The from clause points to the path to the file containing the data. Note the leading /, which denotes the root folder of the data lake store. The final part of the statement is the using clause, which specifies which extractor to use. In this case, the CSV extractor. Our sample file has a header row, so she uses the skip first and row parameter to ignore the first row. Other parameters allow you to set different options, like the encoding or row delimited to use. The extract statement's output is assigned to a row set variable called postcode rows. We can now refer to this row set variable in other parts of the script to progress the postcode data. It's worth mentioning that when the script is actually executed, all commands are reduced to a single execution model. This helps performance. So the engine won't pull data from the postcode file, then execute and the next command in sequence. It will instead determine the next execution plan involving all of the steps and execute in that manner, aiding efficiency. Now that the records has been extracted, they can be transformed. In this case, we want to sum the person total column by each postcode area. Expressions in USQL are written using C# syntax. The postcode column is a string, so the C# string type's substring method is used to pull the first 4 characters of the postcode. 0 means the beginning of the string, and 4 is the number of characters to obtain from the starting position. The data is selected from the postcode rows set variable, and a group by the clause is used to ensure the sum is supplied to each individual postcode area. It is interesting to note that this statement looks exactly like a typical SQL statement, except for the use of substring. This similarity to the SQL language highlights one of the big benefits of USQL to existing SQL developers. The similarity of the language, if you know SQL, you will be able to pick up USQL in no time. If you know SQL and C#, you are already halfway being an expert. The transformed results are assigned to the sum results row set variable, which is returned to the file using the output command. This uses something called outputter to write the output to the required file format. As the extractors, outputters exist for text, CSV, and tab delimited files, and you can write your own using the C#. Output accepts the row set variable to output along with the path. We have specified the output as the folder to store her results file. There's that leading forward slash again. The output folder will automatically be created if it doesn't exist, if it doesn't already exist. An option order by clause can be added to sort the data in the file. And finally, the outputter is specified. This is very similar to the using clause of the extract command, and it can even accept some parameter too. We also want to include column headers in the file, so we need to specify the output header parameter. This sample script represents the extraction, the transformation of data, and the output of file. Thank you. Now it's time to execute the script. You can give the job a name if you want, but you only need to do this if you want to trace the running jobs or maybe order your job history in the future. Let's hit the submit button job. After our job has been submitted, job progress screen appears with the job initially in the preparing stage. A submitted USQL job passes through the 4 stages. One thing you have probably noticed already as this job executes, that it doesn't run as quickly as this simple code should be. The USQL version has been going through now maybe 10 to 15 seconds. This is because USQL jobs are scheduled via a queuing mechanism and executes in a batch-like fashion. Wow, we got some error here. File not found or access denied. Let's look at the name of the file which we have in the storage account. So I am going back to the storage account here and Data Explorer. We created postcode folder. Inside this we have the input file and we see we have a capital D here. So let's go back to the analytics account and view all jobs, and we see the script which we ran and we see the small d in the file name. So let's copy this back and reuse this script. Change this to capital D and resubmit the job. Now again, it will take few minutes. Meanwhile, you remember that this is a big data. So we are expecting some scripts to take a long time to process the information. This is why jobs pass through the queues in the different phases, so we can keep track of them during their execution. We will look at these 4 stages